Okay, section 1.4. Exponents, orders of operations, variable expression, and equations. Lots of stuff here. Exponents, order of operations, variable expressions, and equations. Lots of stuff. Okay, first thing we're going to talk about is exponents. Most of us have seen exponents. We kind of have an idea what we're doing with exponents, or at least what they look like. Let's label the parts of something. So if we were to have something that looks just like this, most of us know that that is 2 to the third power, also called 2 cubed. There's a geometric reference for that. But what that really means is 2 times 2 times 2. So let's label the parts, and then we can kind of define what this is. First of all, the exponent is the 3. It is the small number which is being kind of elevated above the bigger number on the bottom. This, which is the bottom, is what we call the base. So in this case, the 2 is the base, the 3 is the exponent. What an exponent actually is, it's a shorthand notation for the number of factors of the base. Or basically, if we were to write out the base as a multiplier by itself, or times itself, it would be multiplied times itself 3 times in this case. So if it was just 2 times 2 times 2, it's not that big of a deal. We could write that out pretty easily. If you had 2 to the 17th power, you don't want to have to write out 2 times 2 times 2 17 times. So that's why we came up with the shorthand notation, which is what is called an exponent. So basically, it's a way of doing multiplication. Really, that's what exponents really have us do. Couple of different things. If you just have a number, we don't usually say to the first power, but technically that's what it would be. So if I just had 2, it's just read 2. You could also say 2 to the first power, because technically 2 is 2 one time. So it would be 2 to the first power. If we had 2 squared, well, I know that we can go ahead and actually figure that out. It would be read as 2 squared, or 2 to the second power. If we had, once again, 2 cubed, again, that would be read, just as I said it, 2 cubed. The other way to say it would be 2 to the third power. After we get to cubed, every exponent from there on is going to be read as whatever the exponent is to the power. So if we had 2 to the 8th, there's no geometric term like squared and cubed for 8th. And I'll tell you the reason for that here in a second. So this would be read as 2 to the 8th power. Now, if you think of this in terms of what we know as human beings, we have a way to represent something that has 2 dimensions. Something that has two dimensions, if you think about area, like a length times a width, it is a square. If you think about something which has three dimensions, it's got a third dimension to it. It's got a length, a width, and a height. It creates some kind of a volume. It's a cube. After that, three-dimensionally is the highest that we can conceive as human beings. There are probably fourth, fifth, sixth, whatever dimensions out there someplace. We have no concept of this. Our only concept is up to a third dimension. So that's why we don't name anything after after a cube, because we don't have any concept of a geometric shape for that. All right. So example 1. All right, so the first one says 7 squared, or 7 to the second power. Again, that just means the number of factors of the base is 7, is 2. So I would write out 7 times 7. It would be written twice, which 7 times 7 is 49. Not so hard with that one because most of us probably knew that one. Letter B, when you see a fraction, people start to think, oh, I don't know how to do that, but you do. Because 3/7 squared literally means 3/7 times 3/7. There are two factors of 3/7. Well, now it's just multiplying fractions, which you guys know how to do now. Multiply straight across the top and get 9, straight across the bottom and get 49. So 3/7 squared is 9/49. And it really is that simple to do. Okay, now let's talk about order of operations. Okay, most of us have probably learned order of operations someplace in the past, and we used a certain acronym that kind of tells us what things we're supposed to do first when we're simplifying an expression. And most of us have probably heard it called PEMDAS. I'm going to change that just a little bit on you guys, because if you remember, the P stood for parentheses, and that confuses people because it's not just parentheses, which can be done first. And I know it might be something totally, you're thinking, what? That's the way I always did it. Yes and no. We're going to call it GEMDAS. Why am I changing all that? It's not really that I'm changing, I'm just calling it something different so that hopefully it'll make sense. GEMDAS. G actually stands for grouping symbols, of which a parentheses is one of them. There are a lot of different kinds of grouping symbols actually. Parentheses is one. That is a grouping symbol. Another grouping symbol is a squared off bracket. Another common grouping symbol that we've just now talked about is the absolute value, which is the double bar with something on the inside. That's also a grouping symbol. Some of the other common grouping symbols, a root of some kind, a square root or something like that, is a grouping symbol. It groups things underneath of the square root. And then the one that people don't really realize is a grouping symbol, but it is the fraction bar. The fraction bar technically groups the entire numerator and the entire denominator separately. So we don't usually write everything in the numerator and denominator within sets of parentheses, but they technically are. That's a big one. Everything after that pretty much follows what you've known. E stands for exponents. M is multiplication. D is division. A is addition. And lastly, S is subtraction. All right, so we always try to simplify or do what's inside grouping symbols first. That's the order of operations. After you've done that, after you've simplified everything within grouping symbols, then you move on to do exponents. After you've done your exponents, the multiplication and division does not have to be done multiplication then division. Those two things are actually interchangeable. However, while you can do those, and it doesn't have to be multiplication then division, they must be done from left to right, whichever one comes first in the expression. So those have to be done left to right. And the exact same thing holds true with addition and subtraction. Does not have to be done all additions first, then subtraction. You have to do them from left to right. So if you had a subtraction that came before the addition part in a sentence, you do the subtraction first, then the addition. All right, and we'll see that as we go through some of these examples. All right, GEMDAS. Here we go. We want to simplify 6 divided by 3 plus 5 squared. According to our order of operations, we look for any grouping symbols first. We don't have any. So the next thing we move on to is exponents, and I do have an exponent. I have a squared that's attached to the 5. The base is a 5, the exponent is 2. So I'm going to rewrite the other stuff because I'm not using it yet, but I can do the 5 squared, which is 25. Now order of operations say to look for multiplication and division. I don't have any multiplication, but I do have division. So I have to do 6 divided by 3, which is 2, before I can add or subtract anything. And then the last step, because there's only one operation left, is 2 plus 25, which is 27. So there's my order of operations. Now let me show you what I meant before. Letter B says 20 divided by 5 times 4. If you went strictly by GEMDAS, the M should come first before the D. Multiplication, the 5 times the 4. However, that would actually give you the incorrect answer. Remember, the multiplication and division I said are interchangeable, but you must work them left to right. So what we do first is we do the 20 divided by 5 part first. So 20 divided by 5 actually gives us 4, and then continue the problem, 4 times 4 is 16. If you had done it multiplication first, you would have gotten 20 divided by 20, which is 1. That is not the right answer to this problem. The answer should be 16. Again, left to right with multiplication and division, whichever one happens to come first in the sentence. Okay, letter C. 2 times quantity 12 plus 3 over absolute value of negative 15. All right, so what we have is we have a fraction bar. The fraction bar actually separates the entire numerator and the entire denominator, and those two things become grouping symbols. Well, when you have multiple grouping symbols, and again, you would never see it written like this, but this is like saying I have a parentheses here and a parentheses there. Okay, we don't write it that way, but that's like what it's saying. When you have multiple grouping symbols or a grouping symbol within a grouping symbol, you go to the inside-most grouping symbol and do that first. You always work inside out. So what I should see is up on the top there, I have a grouping symbol of 12 plus 3, so I'm going to do that first. And I get 15. I can do the grouping symbol on the bottom separately, and that says the absolute value of negative 15, which we should now know is 15. Okay, so now I've kind of taken care of simplifying for the most part. I still have a multiplication on the top, which is technically within a grouping symbol. However, we're now down to the point where all we have left are factors. You should see that I have a 2 times 15 divided by 15. Hopefully you can see that the 15s will divide out, leaving us with just 2. 2 over 1, which is just 2. And let's do one with fractions in it. 3/2, that's a 2, divided by, multiplied by 1/2 minus 1/2. So again, what you should see there is I've got multiplication and subtraction. Multiplication must come first. So if I multiply across the top and across the bottom. So 3 times 1 is 3, 2 times 2 is 4, and then I still got that minus 1/2. Now I have unlike denominators. I have to get a common denominator. The common denominator should be 4. Multiplying the right side by 2 over 2 will get us that common denominator of 4 on the right. So I end up with 3/4 minus 2/4. Now I now have exactly the same amount of pieces, so 3/4 minus 2/4 is a fourth, 1/4. All right, obviously these order of operations can get a little more intense. So we're going to do one now that's got a bunch of different stuff in it. We're going to simplify 3 plus absolute value of 4 minus 3 plus 2 squared over 6 minus 3. So again, don't forget the entire numerator is a parentheses, the entire denominator is a parentheses. You can kind of work those two parentheses at the same time if you want to, but you do have to work them and simplify them completely before we can deal with the division of the fraction. So what I see on top is I have an absolute value within the numerator. Absolute value is another grouping symbol, so we do it first. So the 3 stays there. That 2 squared on the end is going to stay there. And then I do 4 minus 3 within the grouping symbol, which is 1. And the absolute value of 1 is 1. Okay, I can actually simplify the denominator, 6 minus 3, because it's within a parenthesis, so that's just 3. I'm done with the denominator for now. Now I go back to the numerator and say, okay, I have 3 plus 1 plus 2 squared. I've got two additions, but I have an exponent. Exponent comes first. I've gotten rid of grouping symbols up there, so now exponent's next. So that's going to give me 3 plus 1 plus 2 squared, which is 4. Still over top of 3. Don't be tempted at this point to try and cancel these 3's out. You cannot do that because they are not factors. 3 is not being multiplied on top by 1 and 4. It's being added. Therefore, the 3's do not cancel out. And hopefully you'll see when we're done that that makes sense. I can add the entire numerator and get 3 plus 1 is 4, plus 4 more is 8. The actual answer to this problem should be 8/3. If, for some reason, you'd canceled these 3's out, all I have left over is 1 plus 4, which is 5. 5 is definitely not 8/3. They are not the same thing. So that cannot be done. So let's get rid of those red marks because we can't do that. So this simplifies to 8/3. All right, let's try a couple more of these. More examples, the better off we're going to do. We're going to simplify 3 bracket 4 plus 2 parentheses 10 minus 1, and the parentheses on the bracket. All right, so again, you should be able to see that I have a parentheses within a bracket. So two grouping symbols. I do the innermost parentheses or grouping symbol first. I do the 10 minus 1 part first. Everything else just kind of stays where it's at. Okay, while I do have another parentheses inside the bracket, it's now just 9. There's nothing to simplify inside there because 9 is just 9. So now I'm going to work on the bracket part. Well, the bracket has 4 plus 2 times 9. Multiplication comes before addition and subtraction. So still leaving that 3 on the outside. Can't do anything with the 4 yet, but 2 times 9 is 18. Still working on simplifying the bracket. It's still a grouping symbol. So now 3 times 4 plus 18 becomes 3 times 22. And then 3 times 22, the last thing we can do is 66. Okay, I think that's enough of those examples for you to be able to do those. Now we're going to talk about algebraic expressions. Let's start a new page here. Algebraic expressions. All right, so anything that's an algebraic expression basically is any kind of a collection of numbers, variables, operation symbols, and grouping symbols. So it's any combination of that stuff. Any combination of numbers, variables, operation symbols, which is, you know, plus, minus, times, divide, things like that, exponents, and grouping symbols. So any combination of all that stuff is going to be an algebraic expression. It could only have one of those pieces. It could have all 4 of those pieces. It could have 2 of them. It could have 3 of them. It doesn't matter. If I want to evaluate an algebraic expression, evaluate does not mean solve. There is a big difference. If I ask you to solve something, you must have an equal sign. That's very important. If I ask you to evaluate, I'm just asking you to substitute a value for a number, a number into a variable, and then simplify. So for example, if I want to evaluate the algebraic expression, if x equals 3 and y equals 2, my algebraic expression is 2x minus y. If I want to evaluate that algebraic expression, it simply means to substitute or replace the x with a 3 and replace the y with a 2. Now what's important is that you understand that the original expression 2x minus y says 2 times x minus y. That's what that means. So when I put this stuff in here, it's 2 times 3 minus the y, which is 2. And then it's order of operations. Multiply first. 2 times 3 is 6, minus 2, and then the last thing is subtract. 6 minus 2 is 4. There we go. Okay, same idea if it's division or fractions. 3x divided by 2y. Well, that means on top 3 times x, and the x value is 3. 3 times 3 over 2 times the y value, which is 2. Nothing simplifies, no common factors, so I get 9 over 4. All right. Hopefully that's starting to make sense. I'm not going to do all the examples that they have here in the book, but That's what it means to evaluate. You are simply plugging in the values for x, y, or whatever they give you, and then following order of operations from there. All right, and the last piece is solving. Okay, not to be confused with simplifying or evaluating. Solving means now I'm giving you an equation, and we want to come up with the value of x. So we want to find the value of x. We're not telling it to you, or whatever variable it is. We need to find it, whatever it is that makes the statement true. So, for example, really simple one. If I said x plus 4 equals 7, your job is to figure out what would I have to plug in for x to make that a true statement. Well, in order for me to get 7 on the left-hand side to equal the 7 on the right-hand side, x would have to be 3. And if x is 3, I would plug 3 in and get 3 plus 4 equals 7, or 7 equals 7. That would check out. That's the general idea. So I might give you something that says, determine if 2 is a solution of 3x plus 10 equals 8x. So I'm asking you, I'm not telling you to actually find x, I'm asking you to figure out whether 2 actually works, if this is going to be a true statement. If that's the case, I'm going to substitute 2 in for x and then see if it gives me a true statement. So that would be 3 times 2 plus 10 equals 8 times 2. We'll simplify now and see if this works. Order of operations on the left side of the equal sign. Okay, the equal sign separates these two, so we can do them separately. 3 times 2 plus 10. Got to do the 3 times 2 first. And I can do the 8 times 2 on the right. So now I get 6 plus 10 equals 16. 16 definitely equals 16. Therefore, 2 is a solution to the given equation. We have verified it. Okay, the last thing we need to talk about is writing some expressions, some verbal expressions, and then simplifying those. So if I have something like the sum of a number and 3, and we want to write this as an algebraic expression. Now you can technically use whatever letter you want to represent the number, but a number is something which is unknown. That's your variable. Most of the time they use x, and I think your book even says use x as that. But we have to know some vocabulary. The sum. The sum means to add. So it's telling me I'm going to add some number, which I don't know yet, and 3. So simply that would be a number plus 3. And that's how we would write that algebraic expression from words. There is an entire list of words that help you understand what addition, subtraction, multiplication, division, and equality is. There's a big list if you go to your ebook on page 30. I'm not going to write them all down. It would take too long, but if you come across some words and you're like, I don't know what that means, check it out on page 30 in your ebook. That will help. The product of 3 and a number. Again, keyword, product. Remember that I told you that product indicates that you've multiplied two things together. That's the result of the multiplication. So that means I'm going to multiply two things together. Well, it says I've got 3 and a number. I have to get the product of those, so I need to multiply them together. So that would just be 3 times x. Okay, I'm going to do one more of these. 5 times a number increased by 7. All right, this is kind of important. The comma there actually is going to be a big indicator as to what we're going to do. It actually separates our sentence just like it would in English. 5 times a number increased by 7. So that means I have to do everything up to the comma first. Then I can do what's after the comma. So 5 times a number, that again a number is x, so that should just be 5x. After the comma now it says increased by, which means to add. So plus 7. The reason I bring up the comma because if the comma wasn't there, it would be read the same way, 5 times a number increased by 7. However, that would mean that 5 is going to get multiplied by parentheses x plus 7. And that's going to give you a completely different result because now you're talking about a distributive property. So the comma is going to be important, or punctuation is actually going to be important when it comes to these types of problems. Okay, you should now have everything you need to go ahead and do section 1.4.